Some of the largest and most spectacular fossils from the big badlands of South Dakota are the bones of the huge animals known as brontotheres, or thunder beasts. Native people such as the Lakota and Cheyenne had seen these enormous bones and told stories of enormous beasts that produced thunderstorms running across the sky and called them thunder horses. The big badlands with their eerie, stark, rocky pinnacles and crags were the place of many native legends. In the 1840s, the first early government surveys reached the region and began to collect some of these enormous bones from the Badlands exposures. In 1846, Hiram Prout received a specimen from a fur trader and described this fragment of lower jaw as a giant Paleotherium, a name given by Baron Georges Cuvier to an extinct relative of the horses found in the eastern rocks of the Paris Basin. This was the first named and described specimen of fossil mammal from west of the Mississippi River, one of thousands to come from the Big Badlands in the next century. In 1852, America's first vertebrate paleontologist, Joseph Leidy, wrote that it was the first of many mammalian remains that had been brought to the notice of the scientific world from the vast Eastern Cemetery of Nebraska. In the ensuing decades, most of America's early paleontologists collected extensively in the Big Badlands, especially focusing on the enormous brontotheres. In November 1874, General Ord allowed Yale paleontologist O.C. Marsh and his crews to collect in the Badlands, where they found many spectacular specimens. Marsh got the permission of the Lakota tribe when he visited Chief Red Cloud and his reservation south of the Badlands, and he became appalled at the horrible conditions the Native Americans were subjected to. That winter, he invited Red Cloud east to Washington, D.C., and lobbied President Grant's office and other government officials about how corrupt government agents were stealing from the money allotted to their reservations. But the biggest collections were made by the legendary paleontologist John Bell Hatcher. In 1886, Marsh sent him to the Big Badlands, where in the span of 2 years he collected many dozens of brontothere skulls in the beds from about 34 to 37 million years in age, which now reside in the Yale Peabody Museum. The dominant force in brontothere research was Henry Fairfield Osborn, who in 1891 founded the Department of Vertebrate Paleontology at the American Museum of Natural History in New York. Over the course of about 40 years, as chairman and then president of the museum, he built a world-class institution. He took particular interest in big animals, from rhinos and horses and mastodons to brontotheres. After decades of collecting and research, in 1929 he published a 2-volume monograph over 900 pages long, describing and naming all the brontothere fossils that were known at the time, including many that the American Museum had collected in Mongolia in the 1920s. Unfortunately, Osborn may have been wealthy and powerful, but his ideas about science were outdated and somewhat quirky, such as postulating that brontotheres had evolved from separate origins in parallel many times with 11 separate subfamilies, or imagining that there were tiny horns on the skull that were not actually there, or that brontothere evolution was simply a linear trend toward larger sizes and horns. Like many paleontologists of his time, he gave new species names to every single specimen with slight differences. He did not consider the possibility that the differences between skulls might be normal variation within a biological population, or possibly due to distortion after a specimen had been buried and crushed. The best part of his work was produced by his subordinates, the illustrations done by Osborn's staff, or the analyses by American Museum paleontologist William King Gregory, but most later authors regard Osborn's original work as useless. The legacy of Osborn's gigantic work, full of incompetent paleontology, was that for the next 40 years, no one really wanted to work with brontotheres, because the gigantic mess that Osborn left behind would be an enormous task to clean up and redo. Finally, in 2008, almost 80 years after Osborn's work, a complete updating of brontothere evolution and classification was published by Matt Billbuckler, then a student at the American Museum of Natural History, and now at New York Institute of Technology. Now we have a sound, modern understanding of brontothere evolution. We can begin to see how they really evolved. Brontotheres are members of a group of odd-toed hoof mammals, the perissodactyls, since they have 3 digits on their hands and feet. Some have placed them closer to horses, others to the taper rhino branch of perissodactyls, but there's no clear consensus either way. Their evolution started almost 54 million years ago with beagle-sized creatures known as Lambdatherium, which are very similar in overall shape and size to their closest relatives, the earliest horses and rhinos. Early on, brontothere upper molars show a characteristic pattern, with the outer crest shaped like a W and 2 large cusps on the inside of the upper molar crown. These primitive low-crown teeth were suitable for eating leaves and soft vegetation, but would never be good for eating gritty grasses. About 52 million years ago, we find fossils in Wyoming of a slightly larger genus, Titanotheres, which is about the size of a sheep, about 1.5 feet high at the shoulder. About 47 million years ago, the now cow-sized Paleocyops appeared, particularly in the Bridger Basin of Wyoming, as well as Pakistan. None of these brontotheres had any signs of horns on their skulls, as would evolve later. About 45 million years ago, especially in the rocks of the Uinta Basin of Utah, we see the first larger brontotheres, such as the bull-sized, narrow-snouted Dolichorhinus or Sthenodectes, or the broad-headed taxa like Metarhinus, Mezzatyrhinus, with their deep nasal notches, or Metatelmatherium and Telmatherium, with their short nasal notches and arched nasals. The first paired horns occurred in genera like Manioceros, Diplacodon, and Protitanotherium from Texas, and Rhinotitan from Mongolia. About 40 million years ago, Protitanops from Death Valley appeared, along with Duchesne otis from the Duchesne River Formation of the Uinta Basin of Utah, which also had small paired horns on its nose. Finally, we get to the huge horned brontotheres from beds around 34 to 37 million years ago at the base of the Big Badlands section. Cope, Marsh, and especially Osborne split these horned brontotheres into many genera, including Menotis, Brontops, Brontotherium, Titanotherium, Alops, Menops, Atiliodon, and Oranotherium, with dozens of different species names. In 1989, Bryn Mader published a paper which reduced them to Brontops, Alops, and Menops. But in a 2004 paper and in his 2008 monograph, Milbachler argued that most of the variation of the skulls referred to these different genera can be attributed to normal variation in a population, plus possible differences between males and females, and lots of distortion after the fossil was buried. He showed that there were no longer any strong, objective reasons for recognizing all these genera and species, and so he reduced them all to the oldest name for a horned brontothere based on diagnostic material, Megacerops coloradensis, named by Leidy in 1870. Milbachler supported this argument by showing that large quarry samples of brontothere skulls were highly variable, and even though they represented a single population, they've been attributed to different genera and species. Milbachler and colleagues gave an analogy in the populations of modern giraffes. Within a single population sample, giraffes can have highly variable combinations of horns, as well as bony bumps on their foreheads. Based on this, Milbachler and others concluded in 2004 that the late Eocene brontotheres were all one species. There is one valid species of brontothere between 34 and 37 million years ago in North America, besides Megacerops coloradensis. That is Megacerops cuettagatarinus, which has small forks on the tips of each of its horns. At the same time that the huge horned Megacerops ruled North America, some truly bizarre brontotheres were found in Mongolia and China. First discovered by the American Museum expeditions in the 1920s, these huge umbellotheres had fused the paired nasal horns into a single big battering ram. Now, there are a whole range of brontotheres known from Mongolia, China, and other parts of Asia from 34 to 37 million years ago. Brontotheres are often shown as using their horns for head-to-head ramming, like bighorn sheep. However, this is impossible. For one thing, bighorn sheep have special shock-absorbing adaptations in their skull to mitigate the effects of impact. Brontothere skulls, on the other hand, have only spongy tissue in the skull at the base of the horn. The horns would break off if they slammed into each other head-on. Instead, they probably use their horns to wrestle and spar with rivals, as we see today in rhinos, deer, and most horned ruminants. They may have slammed their horns sideways during sparring, but have never collided head-to-head. Indeed, the mounted skeleton of the brontothere in the American Museum of Natural History in New York has a broken rib on its right side, which re-healed in life. It's so high on the side of the body that it can only have been inflicted by another brontothere. Over a time span of just 20 million years, from 54 to 34 million years ago, brontotheres evolved rapidly into the largest mammals ever to appear on land, and by far the largest mammals in the landscape at the end of their history. Then, around 33 million years ago, they vanished in both Asia and North America. No one knows for sure what the cause of their extinction was, but it did happen during a major climate change, the Eocene-Oligocene transition. In the Badlands, the climate quickly got cooler and drier, and forests nearly vanished, replaced by scrublands. Many other large archaic mammals who were committed to eating leaves also vanished at this time. The teeth of brontotheres are clearly not suited for eating anything else but the softest leaves, could not tolerate a diet of gritty shrubs or the grasses that might have appeared after this climate change. When brontotheres vanished, There were still a few large rhinos around, but nothing reached the size of brontotheres until mastodons evolved around 18 million years ago.